Hey guys, welcome back to the laboratory. In this video, we are looking at the factors affecting reaction rates. By the end of this video, you should be able to identify what has to happen for reactions to take place, describe ways of speeding up or slowing down chemical reactions, and explain how temperature, concentration, surface area, and pressure affect the rate of reaction. So, let's go. In order for a reaction to occur, the reactant particles must collide with each other at the correct activation energy. A collision occurs when two or more reactant particles bump into one another. Only some of the collisions that take place will cause a chemical change to happen. These are the collisions that take place at the correct activation energy. The activation energy is the minimum amount of energy required for a reaction to occur. For example, in this reaction, the reactant particles have not collided at the correct activation energy. The collision is unsuccessful and a chemical change does not occur. However, in this reaction, the reactant particles have collided at the correct activation energy, bringing about a chemical change that forms the product of the reaction. There are four factors that affect the speed of a chemical reaction. These are temperature, concentration, pressure, and surface area. Let's start firstly by looking at how a change in temperature affects the rate of a reaction. When the temperature of a chemical reaction is lowered, the particles have less energy and therefore move a lot slower. Because the particles are moving slower, the chances of them colliding at the correct activation energy is lowered, and so the rate of reaction decreases. In contrast, when the temperature of a chemical reaction is increased, the particles have more energy and therefore move a lot faster. Because the particles are moving faster, the chances of them colliding at the correct activation energy is increased, and so the rate of reaction increases too. In essence, the higher the temperature, the faster the rate of reaction will be. The concentration of a substance is a measure of how many particles of that substance are present within a defined space. If the concentration of a substance is low, then there are fewer particles of that substance within that space. However, if the concentration is high, then there are more. When the concentration of the reactants are low, the lack of reactant particles decreases the likelihood of successful collisions. This lack of collisions means the rate of reaction is decreased. However, when the concentration of the reactants is high, there are more reactant particles present and therefore a greater chance of successful collisions. This increase in collisions means the rate of reaction is increased. The higher the concentration of reactants, the faster the rate of reaction will be. Pressure is a measure of how spread out or concentrated a force is. When a gas is at lower pressure, the particles are spread out and have more space to move within. The larger space means the particles are less likely to collide with one another, and thus the rate of reaction decreases. However, when a gas is at a higher pressure, the particles are more compact and have less space to move within. The smaller space increases the likelihood of the particles colliding, therefore increasing the rate of the reaction. The higher the pressure of the reactants, the faster the rate of the reaction will be. The relationship between the surface area and the reaction rate is probably the trickiest to explain, hence why it's been left till last. Let's use this square to represent a reactant with a very small surface area. Because there is less exposed area for the other reactant particles to collide with, the collisions between the reactant particles are limited, which in turn slows the rate of the reaction. What if we took the exact same square and divided it into 4? Now we have increased the amount of exposed area that is available for the other reactant particles to collide with, such as here, here, and here. Because the areas exposed to react has now increased, there is now more opportunity for successful collisions between reactant particles. Therefore, the rate of reaction is increased. The larger the surface area of the reactants, the faster the rate of reaction will be. Here's an example of a past paper question that I'd like for you to attempt to test your understanding of the content covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. The reaction between calcium carbonate and dilute hydrochloric acid was investigated at different temperatures. Explain, in terms of particles, how decreasing the temperature affects the rate of this reaction. As we've discussed in this video, a reaction will only take place when particles collide at the correct activation energy. The more collisions at the correct activation energy, the faster the rate of the reaction. Changing the temperature of a chemical reaction changes the energy the particles contain, which in turn affects the collision rate between reactant particles. When the temperature of a reaction is decreased, the particles have lower energy. This is our first mark for this question. As a result of the particles having lower energy, they move a lot slower. There's your second. Our final mark is awarded for tying these 2 points together. How do slower particles affect the rate of reaction? Well, slower particles means fewer successful collisions between the reactants. And we know now, less collisions means a slower rate of reaction. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!